remember last time we did partial pressures, right? Partial pressures were kind of easy because what is the formula for doing partial pressures?
P1, P2, or P3, P
However many gases. So basically the formula is the total pressure for a gas, for a mixture of gases, is just the sum of the pressure of the individual gases, right? So if you know what your total is, and you know what the pressure of gas 1 is, you know what the pressure of gas 2 is, but you don't know the pressure of gas 3, how would you figure it out?
Total minus 1 and 2 added together.
Yeah, your total minus your 1 and 2 added together. Whatever's left over is going to be your unknown gas, okay? So partial pressures is pretty easy, okay? Just the sum of the pressures. So now we're going to move on to Boyle's law. Boyle's law, and you're just in part 2 of your packet. Here's the handout. So if you could go ahead and do that data table that's there. I really think the handout that's in your packet is kind of, let me just steal yours. If you keep it open like this, you can see the handout really well and read the numbers well to be able to do that data table, okay? So I would lay it out like this so that you can see it and you can write down your
Does it matter which one we use first?
you start from the, yeah, it will, yeah, go from left to right. All right, so you're just writing down the data. You're just writing down the data from there, reading off the pressures and putting down the volumes. All right, today we went through the ideal gas law, and this is the last law that we're going to be doing in this packet. So the ideal gas law constant is, or the ideal gas law is used to describe the relationship between pressure, volume, and moles of an ideal gas. In this law, there are no initial, no final conditions. You're just going to be given some variables, and you've got to solve for the unknown. Now, this ideal gas law uses a constant called the ideal gas constant. and you'll see gas constant on your reference table. And you'll see that I've given you 3 different numbers. The only thing different between these numbers is that they've been calculated for different types of pressure. For this particular worksheet and for what we're going to be doing on our task cards, we're going to be using atmosphere as the number. Now, we typically write this unit as liters per atmosphere over mole times degree Kelvin. So it's usually not written in a long line like this. It's written more like a fraction. So when we're looking at this, what volume unit is included in the R constant? Well, that would be liters. What pressure unit is in the R constant? Well, the one that we're using today is going to be atmospheres. The temperature unit is going to be Kelvin. And the other unit that's in the R constant is moles. And remember, we also abbreviate that as the number N. Now, the important thing with the ideal gas law constant is, again, you're only going to have pressure, volume, number of moles, and temperature. There's no P1, V1, P2, V2, or any of these ending conditions. That makes picking out your variables pretty easy, because you can just read it along. Moles are going to be N. Anything with liters is going to be your volume. Anything with ATM is your pressure. And anything with Celsius is going to be your temperature. And remember, we're going to have to add 273 to get our Kelvin temperature. Remember, it's important that you always convert Celsius to Kelvin by adding your 273. So here for pulling out our variables for the problem, it makes pulling them out really easy because we don't have to figure out whether we've got a V1 and a V2. We're just looking and putting the variables where they go. So if you have a 55-liter flask, well, liter is a volume, so I can just write that in. It holds 45 moles of gas. Well, 45 moles would be N. With a temperature of 200 degrees Celsius. Now remember, I have to add 273, which means that's going to give me a total new temperature in Kelvin as 473 K. So I have to take the time to do that. And then my pressure is my unknown. So you go ahead and do the other two. Rearranging the formula is pretty easy because it's the same sort of thing we've been doing since we started this packet. When I know my unknown, I'm going to isolate it, so it's right here. So I'm going to take anything that's next to it and put it underneath the other side of my equation. So this is rearranged to T is equal to PV over NR. Do another one over here. So again, this is my unknown. Anything that's next to it is going to go underneath the rest of the formula. So this becomes P is equal to nRT over V. So you go ahead and isolate the next two. Here's an example of a problem, and I'm going to do the next problem. So again, these are really easy to pull out the variables. Right there's my volume because it has liters. Right here must be my N because it's moles. Temperature is 1,400. I'm going to go ahead and convert that to Kelvin. And then pressure is my unknown. Rearrange my formula. Pressure is my unknown. That means that volume is going to slide underneath. So P is equal to nRT over V. Now I'm going to substitute in my numbers. N was 2.31 moles. R is 0.0821 liters, atmospheres, mole, K. My temperature was 1673 K, and that's going to be all over the top of my volume, which was 1.33 liters. Put that in the calculator and you're going to get 238.5. Now I've got to look for my significant figures. I got to go to my original numbers. This one has 3. This one has 3. This one has 2. So I have to round my answer to 2 significant figures, which means 240. Now, if you're not sure about the units, you can also cross off your units and see what you're left with. I have liters here and liters here. I have K there and K there. I have mole and mole, which means my final unit is the only one that's left, and that has to be atmospheres, ATM. Go ahead and try these other 2 problems, and you'll find with the correct number of significant figures, this is going to be 2.6 moles. And when you do your next one, the answer here with the correct number of significant figures would be 2,000. And that's going to be liters, or if you want scientific notation, 2 times 10 to the third liters. So go ahead and work those problems out. And the last thing we're going to do is the task cards.